Now we're going to look at solutions, and in various labs we notice that various solutions can be prepared and actually form liquid states or aqueous states. Most salts, they are actually soluble in water. That is why we know that in general water is indeed a universal solvent. And in this case, once we notice that, then we can play around with making solutions using water, since we know this little fact right there. So in this part, we're going to look at what is a solute versus what it means to be a solvent. So when we're talking about water being a universal solvent, we know in this case that a solvent is a larger part of this particular preparation, and since it is a larger part in this particular, I would say, process, it is also known to actually do the solving. So doing the solving means that you are the solvent, and while on the other hand we have the solute, and the solute is the smallest or the smaller part of this particular process, and in this part it's actually breaking down its solid states. Or in this process we are being dissolved. Like for example, we have table salt, which is NaCl, and NaCl is well known to be sodium chloride, while for solvent we know that an example is water. Looking at this particular diagram right here, we notice that we are adding a solute and dissolving it in a solvent. Now that's out of the way, we're going to dive into detail what is molar concentration. Now think of this as when you're adding something into a particular solvent, what we notice is that as we add, we are taking into account not only the volume of your particular solvent, but you're also taking into account how much mass you're actually adding based on the solute. So in this case, you need to take into account the mass of the solute and also the volume of the solvent, only if you're making a solution from a solid solute. So the solute molecular mass will be taken into account in order for we to be able to get the moles. So if you look at your mole highway, we're going for moles, or for mass, sorry, all the way to our number of moles. To get to that, we need to be able to divide our mass by the molar mass of our solute. Like in this case, we have 3 mole per liter of NCl, which is hydrochloric acid. So in here we're going to take into account the molecular mass of hydrochloric acid, which is, first look at the hydrogen's molecular weight plus that of chlorine, or in this case chloride, molecular weight. So hydrogen is 1.01 plus 35.45 for Cl, and that gives me around, let's say, 36.46 grams per mole for our molecular weight of hydrochloric acid, where the big M is represented as the molecular mass or molecular weight. Now, that being said, once you're able to figure this molecular weight out, then you can actually transform the mass of your particular solid state of hydrochloric acid into the moles, and from there we take into account the total volume of your particular solvent, which is right here, and that will actually make us to know the molar concentration. So the molar concentration in here is actually determined by getting the number of moles of solute, which is measured in moles, and you divide it by the volume of the solution. And the volume of the solution is mainly the volume of the solvent, measured in liters. So our standard unit for moles is moles, and our standard unit for the volume of a solution is liters, and then the unit of concentration, which I'll put as molar concentration, to be C. Let me erase this and make this cleaner. So the unit for the concentration is equal to mole per liter. So if you want to get the concentration of any solution and you're given the mass, you have to transform the mass to moles, and if you're given the liters to be either centimeter cubed or milliliters, you have to convert it to liters. So by that way we can be able to get our units in terms of mole per liter for the concentration. So preparing a solution in the lab, in this case there are two ways to prepare a standard solution. One way is by making a solution from a solute. So now in here, to get to that, we need to keep our volume constant. That is what you need to take note of. So keeping the volume constant means that as I'm adding more of my solvent, my solute, what is happening now is my concentration actually increases as the number of moles being added, which is either represented as M, which is less of the standard, and more of the standard being the number of moles, increases, our concentration increases. So in this case there is a direct relationship between the number of moles and the concentration, and that is where the formula comes into play. C is equal to NV, where C is actually the concentration, then N is equal to the number of moles, which is measured in moles, and then the volume, make this V, is measured in liters, and this is kept constant by just using a volumetric flask. And take note that sometimes if you're given milliliters, to convert from milliliters to liters, we need to know our conversion rate, which is 1000 milliliters makes 1 liter. This is just for future examples.